Hello everyone. LUMILOOP specializes in turnkey solutions for energy and data transmission over glass fiber, delivering ultra-miniaturized systems, from sensor to software. In this video, we'll demonstrate the radar pulse measurement capabilities of LUMILOOP devices. Both the LSProbe E-field probe and the LSPM RF power meter are equipped with envelope detectors featuring fast rise time, enabling superior sampling speeds, high accuracy, and exceptional dynamic range. Thanks to their extremely high sampling rates, they can accurately measure pulsed E-fields and RF signals with pulse widths as short as 500 nanoseconds. Let's begin by taking a look at the measurement setup. We're using the Rohde & Schwarz SMA100B signal generator to simulate a narrow pulse source. The output is connected to a Vivaldi antenna via a directional coupler. The forward and reverse channels of the coupler are connected to the LSPM 1.0 RF power meter. To measure the radiated signal, we're using the LSProbe 2.0 paired with the CI250 Plus computer interface. The CI250 Plus also acts as an external trigger source, synchronizing with the LSPM 1.0 through a BNC cable. Now, let's configure the signal generator. We'll switch to pulse generator mode, set the pulse period to 1 millisecond, and the pulse width to 3 microseconds. Then, we define the frequency as 1.3 GHz and set the RF output level to 20 dBm. Finally, we enable the RF output. Next, we'll move to the LUMILOOP GUI. We begin by enabling the laser and setting the mode and frequency for both the LSProbe and the LSPM. The LSProbe will immediately start displaying real-time measurement values. To visualize the pulse signal, we switch to scope mode in the LUMILOOP Expert GUI. Here, we select normal trigger mode, set the trigger source to any rising edge, and enable the BNC output. This allows us to capture the EM pulses clearly within the defined time window. We'll also configure the scope graph settings for better visualization. As we vary the orientation of the LSProbe, you'll notice that the measured values change accordingly. Now, let's switch to the LSPM scope mode and configure the trigger settings. This time, we select External BNC Rising Edge as the trigger source. With both scope views active, you can observe the same pulses detected by LSPM and LSProbe at the same time. To enhance the LSProbe performance, we'll switch its operating mode from mode 0 to mode 8. This increases the sampling rate to 1 megasamples per second. With this change, the LSProbe can now detect narrow pulses down to 1 microsecond with much greater stability. The LSProbe 1.2G variant can measure extremely high electric fields, up to 15 kV per meter, making it the perfect fit for defense applications. Besides pulse measurements, LUMILOOP devices deliver exceptional performance for a wide range of advanced and standard EMC applications. From shortest pulses to continuous wave, LUMILOOP is the perfect choice. For more details, please contact us.
LUMILOOP. We focus on lasers to make you shine.